Hello there, welcome back. We have Mr. Kanishka out here. Welcome, Kanishka, to Mumbai Summit. And then we have some again interesting topic out here. Building a good data infrastructure, how important it is, right? I'm sure it is. So over to you, Kanishka. Not much of a time from my end.
Thanks, Santosh. Thanks. Good afternoon, everyone. Good to see this on a virtual summit right now. I think we've got about 15 minutes or so, and we'll run through some of the areas of data infrastructure and what it takes to build a good infrastructure in place. But I wanted to start off with a bit of a story, and this is something close to all of us. Most of us have experienced this in our personal lives. And think of somebody who is a 3, 4 year old child trying to learn the way to count numbers. And children, the way they count numbers is generally using their fingers, right? So they go with 1, 2, 3, 4, 5, and then use the next 5 digits and go up to 10. Typically, a child at that age is, usually stops at 10. Number 11 becomes a bit of a difficult issue because they just don't know where to place that number 11 on their 10 fingers. And then you start introducing them to, maybe you could use your toes, maybe you could use these little demarcations on your hands to count the further numbers. But essentially, they still run out of it, and it becomes very difficult for them to comprehend what is that next number which cannot be accommodated on their digits, and how do they comprehend that number, which is when you start telling them between the units and the tens and the hundreds and the thousands. So those demarcations between the numbers start coming in. What essentially is happening is they started off with some data, they ran out of space for that data. This Because they ran out of space, and they also, the complexity of the data increased, it became a little difficult for them to comprehend and understand what that data signifies to them. So in their universe, that data is an extremely difficult paradigm shift in terms of what they've been exposed to what they need to be. It still exists in what we call as the multiverse, but in the universe of their own, it is pretty difficult. Organizations grapple with something very similar. They also have a lot of data that they're today sitting on, be it in public enterprises, commercial enterprises, but a number of them have a ton of data that they're sitting on. But most of them don't know how to make good use of their data. This is that standard big data problem. So, there's a lot of data which we call as big data, but unfortunately, there are no systems, or there is not the underlying infrastructure for you to comprehend, understand that data, and come up with meaningful insights. In fact, somebody was just telling a while ago on the previous panel, right? It's not good to have just data. It's important to have good insights of that data, how it is presented, and how you tell a story on that data before you can start bringing in any kind of value creation activity using that data. So I'm going to share a couple of slides, and we'll try and keep this slightly lower in terms of technology, but I want to get to the broad business understanding of how you would build a good infrastructure in place, right? So one second while I pull this up.
Yes, Kanishka, right. You can go ahead.
So, sometime back, and I'm probably sure in 2019, if some of you are avid gamers, you would have seen something called, or a game called Fortnite. Now, Fortnite was, a raging game, or is still a raging game, with about 125 million users. Essentially, the game is more of a lot of players collaborating to probably fight off a mysterious storm, or a number of them actually fighting to be the last man standing. It's a free-to-play game, but what the game really makes money is on those in-game microtransactions, as we speak about. And the game really learns from the transactions that you do, the behavior that you do, the strategies that you use, the way you navigate the game itself, the weapons that you may use to change at each point in time. And this is all real time. This is all happening at real time. So Epic, when it wants to launch a new feature, all they do is they can actually launch it and know immediately within a span of a couple of minutes if that new feature is being picked up or not being picked up. The way they have done it is an absolute constant feedback loop that they have with their users, which are the players, as well as with the game designers, so that on the fly they can start changing this. Now, how are they really accomplishing this? In essence, they are using a ton of data. This particular game is about 14 petabytes of data is what they have, and every month or so, they have about 2 petabytes of data coming in. So there's a data lake itself which exceeds 15 to 18 petabytes. That's the data lake that they're sitting on. On top of that, they're running multiple services. Now this is probably on AWS. So they're running a number of AWS services that helps them understand this data. So the data is streaming in. They're able to drive insights on it. They're able to drive analytics, which are both batch processing as well as real-time processing. So they're able to get a number of specific touch points on data, going to a micro granularity of per player kind of data, that they're again pushing out for micro recommendations. So knowing you as a player, if you're more tuned to buying, say, a weapon versus changing a scenario in a game, then I would push out a specific recommendation for you to buy a weapon rather than a change of scenario in the game, right? And that enhances my microtransaction. It also enhances customer satisfaction at the other end. What they've done is essentially built a very scalable, resilient data infrastructure in place. You today typically are looking at these specific silos, right? Or points in terms of your data. You know your data is growing exponentially. Take the example of a child that I said, which is data going from single digits to 6 or 10 digit numbers very quickly if you had a large application, or even in this game like Fortnite, where it went from 14 petabytes to 2 petabytes every month. So in a year, you could be looking at easily 24 to 30 petabytes of data being ingested into your data lake. They're coming in from different sources. So today you could have data coming in, whether it is the game or any kind of other device. Look at agriculture itself. You could have data coming in from satellites. You could have it coming in from the farm using IoT, data coming in from possibly the panchayat, from any other place coming in. So how do I start bringing in these siloed databases into one place, which are also very diverse? And then finally, I want it to be used by multiple people. Take data, and I want to use the agri example because that's very pertinent to our country. Now, the agri data, I want it to be consumed by the farmer. I don't want it to make it a lot more complex than what he can comprehend, but something that I can push out on his feature phone. He probably does not even have a smartphone. So something that just tells him when should he be sowing and when he shouldn't be. And all he needs to know is the dates. He should also know what is the the condition of his soil, when should he be buying a particular fertilizer, and so on and so forth. But then I need a lot more granular data that could be used possibly by the agri ministry, possibly by the panchayats, maybe also organizations or these agri-techs that are providing these solutions. So therefore, I need that data to be simple enough to be consumed by the lowest common denominator, but also complex enough for any kind of further analysis to be done on it. Which brings us to how companies are today using this data. They know that a siloed approach doesn't work. We're slowly moving away from an on-premise kind of a setup because they realize that it's fairly limiting. Take the example of the game of Fortnite itself. If somebody is looking for an exponential rise on their data, then an on-prem data center will fail right from the start. Also, you would have scalability, you would have resiliency issues. It's extremely expensive. You could have spikes coming in at certain points, and then it drops off. So how do I start utilizing capacity that I provisioned for, but is now just lying isolate or dead for the moment? So you need a different way to start bringing all of this together. And that's what brings us to how you would typically do a general data lake, right? Which is the foundation for any good data infrastructure. A typical way of doing it, and what everybody is attuned to doing it, is that you try and set up a storage. You look at multiple databases, devices, where it is all coming in from. You start bringing that all together into a storage block. You then start moving all of this data also into a way where you can start cleansing and prepping, cataloging all of that data, which is our ETL layer. So you start bringing all of that together. You obviously enforce security and compliance policies, and then you make it available for analytics. Now, there are at least 5, if not more, steps involved. We are now moving away from all of these steps. We are slowly beginning to get to a point where a number of these are automated. So I don't necessarily need to now set up storage, move data, and cleanse and prep, because this can all be done at a single point. I can then also make a single data lake call and say, I would like to set up a data lake completely from scratch, and all I will do is point to the source of data and what I need to be done of that data, and the system takes care of it all. So it's kind of disrupting the way we have been doing all of the ETL tasks of actually setting up a data lake. So data lake by itself has become a single function to start off with, which helps us then go into some higher end activity, which we'll see in the next slide, is how would you actually be able to drive analytics on it, put out AIML algorithms, drive further insights on this. And that's why we look at that customers are essentially looking for one single cohesive data store that is scalable, that's cost effective. And obviously it follows all of the security parameters. You're able to analyze it differently in whichever form and fashion. But essentially, you would start bringing all of these into a sort of a cloud data lake. Bring it all together. You would have it all decoupled in terms of storage and compute resources. All you need to do is pipe your data and your streaming services into the data lake, and keep the top layer, which is your ETL and catalog management, your security governance, is again a very containerized function, leaving the high-end activities of any kind of processing, any kind of analytics, any kind of AIML that you want to put as a wrapper around it, which is where you want to spend most of your time. So, putting it in a very normal parlance, right? I'm no longer looking on building a car. I know how to build a car. I know it needs four wheels, it needs a steering, it needs a gear shift, and so on and so forth. What I'm looking for is further enhancement and fine tuning of that car. I want it to go much faster. I want it to be a lot more efficient when it comes to fuel. So those are those value adds that I want to bring in as far as my overall data infrastructure policy and my strategy is concerned. If you look at how you would design it for the future, you typically would, and this is splitting down into a very logical scenario, right? You want to harness your data warehouse. So we're not saying that, well, the data warehouse is going away. No, it's not. It's probably going to still sit there. How you leverage the data warehouse, whether it is a SQL or a NoSQL or any of the other object-oriented storage mechanisms, that's a different story and not something which I'm getting into. But in essence, I want to still have my data warehouse talk to my data lake at every point in time. So that continues to be my one single container. I would like to catalog all of this information. There's a ton of work that today goes on, what we call as both in terms of human annotation as well as machine assisted annotation. And in some cases, human augmented annotation that may happen. So I may want to start crowdsourcing a lot of this activity in terms of annotating that data. So how can I provide images to people that before the machine starts cataloging them as a particular object, so whether it's a dog or a cat, I have humans actually look at it and say, okay, well, this looks like a dog, but this, by the way, is not a cat, it's actually a pug, because a pug and a cat have very similar features. So I would bring in that human augmented crowdsourcing annotation piece over here, which can also be as part of your cataloging, on which you can start running your queries. Now, whether you want to run a SQL query, which makes it very accessible for the rest of your organization. Your rest of your organization can almost become a Q&A or a QA, quality assurance or a testing, because everybody is then able to drive SQL queries on that. They're able to find out insights into data that you are not able to find out and actually come up to you saying something's not looking right. So whether do you want to do that, whether you want to make it a real time like what Fortnite is doing or what a number of media and streaming companies do, or you want to make it interactive like a number of COVID dashboards today do, that's up to you. That after that, the wrapper or the front end that you push out is completely dependent on the application, the responsiveness, and the business need that you have. You can put it. But for that, you will need a lot of compute facility. Now, an on-prem compute facility, which is server-based, can be sometimes cost prohibitive, sometimes prone to limitations. So you would want a limitless scalability. And then you also want to make sure that your entire big data systems are absolutely distributed. So you could bring all of this together as part of, let's say, a cloud infrastructure policy that you put out for your organization. So finally, with what I would want to have all of you look at is, when you put out a good data infrastructure model, you are essentially looking at, one, how do I move my data? to wherever it needs to be, which is into the data infrastructure, the data lake itself. So what is my mechanism to move them? Is it the most efficient mechanism, or do I need something at source? Take smarter cities, for example. Do I need the videos that are used for surveillance or any kind of capturing at a particular traffic signal? Do I want that data to be moved to my data lake and then processed, sent back for any remedial actions? So can I do it at the edge? Again, a business call, right? You want to have that latency to be built in or not. The second is then you look at the overall infrastructure for the data lake itself. What kind of data lake are you looking for? Is it something that is probably not going to scale and it's going to remain possibly static at a longer period of time? Maybe you're better off at an on-prem, but if it's going to scale like most data lakes do, then you may want to look at a way of mechanism that helps it scale up and scale down as demand grows up and down. And finally, on the analytics that you want to run on it, what kind of analytics? Do you want to do just regular data warehousing or any kind of big data, or do you want to do serverless data processing, which is at any point in time, I want a particular script to be run if so and so activity happens, which enables me to not call or dedicate a certain compute function just for that, which is generally lying. So, I could be deploying a particular 5 CPU core or any of those, but if I'm not using that for greater than 23 hours in a day, then do I need to have a dedicated compute capacity, or can I actually just be making a call when I need it? So again, something to be considered as part of your overall architecture. And then the overall queries that you would run, the analytics that you would want to drive in. So any of those functions, again, a business call for you to take. Finally, on top of that is your front end, right? How do you want it the dashboard to be looking at? Or is it not a dashboard? It is something that's a feedback loop like the game we spoke about. Or is it something around prediction? Is it a digital user engagement like an airline or an airport might put out on their website? Or maybe an e-commerce firm might put out on their website. So how do you want any of those to look like? Would help you get to the relevant answers if you had a model like this in place. So with that, I will pause and take questions at this stage.
Sure then. Thank you so much, Kanishka. So quickly, if you have questions, yes, there's one from Gautam, if you can see in the question section. How should we take care of data quality and data governance capability in the data infrastructure?
Yeah, so I think from a quality perspective,
your voice is not audible. Can you just mute and unmute?
Actually,
not yet.
Is it better?
No. Can you?
Yeah, I didn't do anything.
Mute and unmute the button in the bottom if you can do that. Okay.
Any better?
We don't hear you. Better? Okay, we can hear. I'm sorry.
Okay.
I'm sorry. It's me. I'm sorry.
Okay.
It's me.
No worries.
Really sorry.
All right. So I think on the data quality, right? So we I think as all of us who live in and out of data, and we've gone through garbage data a number of times in our lives. You put in garbage, you will get garbage out. You would want to drive data quality primarily from the culture that you drive in a particular organization. That's one when you're seeking data. So how can I actually have a particular organization put in good data is when I can start incentivizing people that can plug in the right data which helps them in the feedback loop. I'll give you an example where we had a particular customer that was trying to put out a maintenance solution. Now the maintenance solution was such that prior to putting in, people would just put in n number of values because they knew nobody was looking into it, and they would feed it into the system. So for every problem that the plant was down with, they had the same answer, and they had the same answer because people ended up choosing the first one in the drop down list. Now we wanted to obviously correct that behavior, and we said, okay, if you start putting in the correct values in the drop down list, this can help predict it faster for us. You don't have to go and look through manuals, and you can actually know exactly through the system what is the issue and solve it. So the data quality is one, but beyond that, yes, there is the entire cleansing piece that happens. There is the rejection of bad quality data. There is possibly some pieces of regression and ML techniques that you would use to gauge and predict what that data series could be. So you would have all of that. The governance is where you would, is an important question and goes beyond the tech community or people who are close to the data. I think governance has got to do more with your policymakers, the way you want to bring it all in, whether it is SPI data, PII data, or whether it is data that can be used for multiple reasons and issues. Again, the organization helps define a number of these policies for people to start bringing in. So hopefully that start answers this. These are less of tech problems, but more of governance slash policy areas to be concerned with.
Sure then. So thank you so much, Kanish. We're just running tight on the schedule as well. So audience, if there's any other question, please just drop it into the team. So we're going to get back. We'll make sure that Kanishka is going to answer to you offline. Okay. Thank you so much, Kanishka. I think
Thank
audience,
you, Santosh.
you can applause. Big round of applause to Kanishka. Okay. Thank you
Thanks,
so
guys.
much.
Thank you very much.
Thank you so much. So we're going to be back with the next session in a minute's time, not more than that. Thank you so much, everyone.